So this is the guide for the Chapter 9 quiz over quadratics, and it's about solving quadratics and applying word problems to them, and the occasional finding of the vertex as well. So we'll start with the basic ones, which is solving the quadratics. So remember, we have three methods of solving quadratics. We have factoring, which is probably the most efficient method if it's possible, although it's not always possible. We have completing the square, which can work in most of the cases, but can get kind of nasty decimals here or there. And then we have the quadratic formula, which is probably the longest of the three, but it can be used for any single occasion. So it can solve any quadratic we have, but it is a little bit longer to use. So which method you choose is up to you. I'll try to use a varying sort of methods here, but most people just default to the quadratic formula if the factoring looks too difficult or complex. Now, for the quadratic formula and for factoring, the problem has to be zeroed out first. It has to start at 0 or be equal to 0. So in the case of number 1 here, the first thing I might want to do is subtract this 9x from both sides, because I need to zero it out somehow. So this goes away, get a 0. Over here I have 4, and I'm going to put my minus 9x in the middle, and then 2x squared off to the side here. And the reason I put it in the middle, and I should probably put a plus between it and the 4, so let me kind of rewrite that. 2x squared minus 9x plus 4. The reason I put it in the middle is as that's how most people are used to seeing it, as x squared x and then non-x. So putting it in the middle just kind of helps keep that routine. Now I could try to factor this using the slide divide trick or just normal factor guess and checking, but in this case I'm going to default to the quadratic formula just because I really don't want to bother with the slide divide trick or just basic factoring there. So in this case, I have a is 2, b is negative 9, and c is 4. It's always in that order. A is the x squared number, b is the x number, and c is the non-x number. So if we put this together, remember the quadratic formula looks something like this. Opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So I'm just going to plug in the numbers in my equation for the appropriate variable. Opposite of b, well, b is negative 9, so it'd be positive 9 plus or minus the square root of negative 9 squared minus 4 times a times c all over 2a. So 2 times 2. Now, to save myself some space, I'm going to kind of skip over some of the basic calculations here. So let me pull this up here. So 9 plus or minus the square root. Negative 9 squared is 81, because negative 9 times negative 9 is 81. And then 4 times 2 times 4 would give you 72. And so when you take 81 minus, or sorry, 32. So 4 times 2 times 4 is 32. My bad. So when you take 81 minus 32, you get 49. All over, and then 2a, well, 2 times 2, that's 4. Again, I'm going to skip over some of the middle calculations there just so I don't run out of room here. And so this is the point where you actually split it, because the square root of 49 is both a positive and a negative number. So we'd have 9 plus 7 divided by 4. Again, 7 is the square root of 49. And 9 minus 7 divided by 4. Well, if we do, again, some quick calculations, 9 plus 7 divided by 4 is 4. 9 minus 7 divided by 4 is about a half. So my two answers are x is equal to 4 or x is equal to a half. Now, know that these are indeed points on a graph, so if you want to write them as a point, it'd be 4 comma 0 and 1/2 comma 0. But writing it like this is fine, because since it's implied we're finding the intercepts, we don't have to write the actual point of it because it's an intercept, so we know the y-coordinate is going to be 0 anyway. So just writing the x-coordinate is fine in this case. For number 2, I could use the quadratic formula and probably have a quick time with it because my b value would be 0, so all my b's would be 0. It would make it a lot easier to do. But this is actually one of those special factoring cases. So remember, in this case, it's called the difference of squares. Your first number is a perfect square because it's n squared. So by definition, it's a perfect square because it's simply something squared. And then 64 is also a perfect square because square root of 64 is a nice whole number, in this case 8 times 8. So because both my values are perfect squares, and because they're being subtracted, I can factor it like so. The square root of n squared is n. The square root of 64 is 8, so it's n plus 8 times n minus 8. Again, this is called difference of squares, or the factoring a difference of squares, because your first number is a nice perfect square. Again, it squares to a whole variable or a whole number. Your second number is also a nice perfect square. In this case, squares to 8. So you write it as blank, or variable plus number times variable minus number. So same thing, just different operations. And so this is still equal to 0. And so this answer gives me negative 8, because that's what makes that 0. This gives me positive 8, because that's what makes that 0. So those are my two answers there. N is equal to 8 or negative 8. Again, in this case, I'm solving by factoring, and the way I'm doing it is just after I factor, I figure out what number would make each set of parentheses 0. So in the first case, n plus 8, n would have to be negative 8 to make that 0. In the second case, n minus 8, n would have to be positive 8 to make that 0. So that's why I have my answers as negative 8 or positive 8. And the last one here, for the first set, we have x squared minus 10x plus 18. In this case, I don't believe there's really any numbers that multiply to positive 18 and add to negative 10. You think 6 and 3, but those would add to 9. 2 and 9, but those would add to 11. So there's really nothing that would multiply to 18 and add negative 10, at least not off the top of my head. So in this case, I'd be using the quadratic formula. And so remember, in this case, this right here means that your a value is equal to 1 because there's no number in front of the x squared, so you assume it's a 1 there. So we're going to plug the stuff in. So we have the opposite of b, so positive 10 because b is negative, plus or minus the square root of b squared minus 4 times a, which is 1, times c, which is 18, all over 2 times 1. So again, I'm going to skip over some of the middle calculations here inside the square root. So negative 10 squared is 100. 4 times 1 times 18 is 72. 100 minus 72 would give me 28. All over 2 times 1, which is 2. So again, this is where I'm going to split. And I have 10 plus root 28 divided by 2. And 10 minus root 28 divided by 2. Now in this case, you just plug them in the calculator to get your rounded decimal. So here I have 7.645, and here I have 2.355. Now usually you can just round the second decimal spot, at least for me, but I just wrote down a little bit extra decimal spots just to be sure. But again, after you make your split, you just plug it into a calculator because you probably can't do the square of 28 in your head, and just go from there. So in this case, these are my two answers. X equals 7.6 something or 2.3 something. So that is the three basic ways, or at least two of the three basic ways of solving quadratics. Again, completing the square is not one that's often used. Most people default to factoring or quadratic formula. And in fact, most just default to the quadratic formula. But completing the square is not a bad thing to keep in the back of your head. Now the next part will be solving systems of quadratic and linear equations together. So that means that, remember when we're doing this, we're basically having a parabola here and then a line going through it, and we want to find out where are these two intersection points occurring. That's what we're finding out when we have a system like this, is that there's a parabola, there's a line that's cutting through it. Where are they going to cross, if at all? They might not cross at all, in which case we have no solution. But we want to find out would they and where would they. Now to solve this, all you need to do is notice that this big chunk of information is equal to y. And this chunk of information is also equal to y. So if these are both equal to y, that means they both have to be equal to each other. Because the y's are certainly equal to each other. Y is the same as y. So these two y's are the same because they're both the same variable. But, and I should probably make that 6, a better 6 there. But if both my equations are equal to the same thing, then they have to be equal to each other. It's like saying, in some case, if I put it into arithmetic form, 5 is the same as 1 plus 4, and 5 is the same as 2 plus 3, So because 1 plus 4 is equal to 5 and 2 plus 3 is equal to 5, that means 1 plus 4 is equal to 2 plus 3, which of course is true because they're both equal to 5. That's the same kind of logic we're applying here, just with variables and equations rather than numbers. Same style of logic. And so what we're going to do now is do what we did on the top part and solve this. Now, again, we can't really solve it right now because we have our x's split. So what we're going to do is try to zero out a side. So we're going to try and make this into a zero problem, just like on the top page, or on the top part. So we're going to subtract 3x first. I get 6 is equal to x squared minus 10x minus 15. Then I'm going to take away the 6. I get 0 is equal to x squared minus 10x minus 21. And then here I would probably think if I can factor first. So two numbers that multiply to negative 21 and add to 10. There's 7 and 3 add to 10, but one of them would have to be negative in order to make a 21, so that wouldn't work out. Other than that, I don't think there's any other numbers that add to 21 except for 21, or multiply to 21, except for 21 and 1. So this is another case where we can't really factor because the numbers just don't work out. So we have to default to either complete the square or probably more accurately the quadratic formula. So once again, opposite of b, plus or minus the square root, b squared minus 4 times a times c all over 2a, which in this case is still 1 because there's no number in front of the x squared. So we do some arithmetic here. 10 plus or minus, again, I'm going to do the arithmetic inside the square root without writing it down. So negative 10 squared is 100. 4 times 1 times negative 21 is negative 84. So in this case, actually I'm going to write this out here just to show you what happens. So this is 100, negative 10 squared, minus parentheses, 4 times 1 times negative 21. Well, that's going to be negative 84 over 2a. So what happens is that minus negative 84, remember, if you have a double negative, that means that's going to turn to a positive. So it's actually going to be 100 plus or minus the square root of 184, because we're going to add them together, all over 2a, or 2. So you have to be on the lookout for that double negative when it happens, because it's a very easy thing to mess up, especially when there's a minus sign already there. So just make sure you're careful on your double negatives. And then from here on out, it's the same old, so you split it up. 10 plus the square root of 184 over 2, and 10 minus the square root of 184 over 2. And you get two different answers. For this answer, 10 plus the square root of 184 divided by 2, we get 11.78. And for 10 minus root 184 divided by 2, we get about negative 1.78. So these would be my two answers. And because I'm just finding out a general problem, that would be okay. Now, we're not actually done yet. These are actually my x answers. But because I want to find the point where they cross, I need to plug these back into one of the equations. So remember, my original equations were y equals x squared minus 7x minus 15, and y equals 3x plus 6. And I want to find out what is the point where these two graphs cross. Well, I found the x-coordinate where they cross. Now I need to find the y-coordinate where they cross. And so what you can probably expect that we're going to have to do is plug those x's back into one of these equations to get the y value. Now, because linear equations are a lot nicer and simpler to use, we're going to use the linear equation as my plug-in equation. So I'm going to first check the positive answer. So y equals 3 times 11.78 plus 6. So we do some quick math there. 3 times 11.78 plus 6 would give me 41.34. So my first point of intersection is 11.78, comma 41.34. And then I'm going to check my negative answer. I'm going to do that all the way around here. A lot of arrows in this one, sorry, it's just a lot of work here. And so we get y equals 3 times negative 1.78 plus 6. Do some quick math again. We get our answer of 0.66. So my Last point would be negative 1.78, 0.66. So this would be my, or these would be my 2 points of intersection and my 2 final answers. So in this case, your answer is a point that you need to find both the x and the y, kind of like the vertex, because you need them both in order to get the point accurately. For just the x-intercepts one, like we did the first 3, you don't really need the y-coordinate because that's going to be 0 because you're finding the intercepts. Here you're finding the intersection, which might not be a y-coordinate of 0, so you have to actually find it out. And then there's one, well, kind of 2 last ones here, based on the same word problem. So we can go there. There we go. So we have a ball. It's being thrown upwards. The height is given by the equation, and we want to find out first how long does it take to reach the ground. Well, the key word here being reach the ground. So the ground implies that this is a intercept equation, because if you're reaching the ground, that means you're ending or you're finishing, or it's 0. So in this case, we're trying to find the x-intercepts, which means that we're going to be trying to find the, we're going to be using the quadratic formula. Or again, you technically could factor or complete the square, but quadratic formula is probably going to be the nicer one. So again, anything talking about reaching the ground or reaching the end or reaching the water, that's going to be an x-intercept implication. So this means x-intercept. So let's run through this then. We're going to make sure we set this equal to 0. So 0 equals negative 5t squared plus 14t plus 3. And we're just going to plug in our numbers to the quadratic formula. So opposite of b, so negative 14, plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. Remember, a is negative in this case, so don't forget to include it. And then we just go through the same procedure last time. So we do negative 14 plus or minus the square root. Again, do some quick math inside the square root on my own here. 14 squared is 196. 4 times negative 5 times 3 is going to give me negative 60. So it's going to be 196 minus negative 60, which is like 196 plus negative plus 60, which would give me 256. Again, just be on the lookout for that double negative that's going to occur there. So it's because I have a negative here and here, that means I know my answer is going to result in a positive when I'm going to add them together, because that 4 times negative 5 is going to give me a negative number, and then when I subtract it, it's going to turn back to a positive number, because again, I have that double negative going on like the last problem. And then we divide it by negative 10. So I'm going to split this now, because I'm at the point where I need to split. We have negative 14 plus 16 over 10, and we have negative 14 minus 16 over 10, and both these 10s are negative because my 5 was a negative. And so I have 2 answers. The first one up here will give me negative 0.2. Down here would give me positive 3. And my goal is to decide which one makes the most sense. Will it hit the ground in negative 0.2 seconds, or will it hit the ground in 3 seconds? And in this case, 3 seconds seems to be the more reasonable response, because we can't have negative time. So in word problems, you have to kind of discern which answer makes the most sense. And usually it's going to be the positive answer, because negative answers when dealing with time or height or whatnot don't really make a lot of sense. Then the last question here says, what is the maximum height of the ball? And this word there being maximum should clue you in that this means vertex. So if you hear the word maximum, minimum, lowest, highest, most, least, those are all vertex words. So make sure you read the problem carefully and figure out which type of application will you need. Now for the vertex, it kind of came in 2 parts. We had a short little formula. The x-coordinate of the vertex is that opposite b over 2a part. So basically the quadratic formula without the square root. So the vertex, it says, okay, use this little formula here to get your x-coordinate. So we'll do that real quick. Opposite of b, so negative 14 over 2 times a. You can do some quick math here. Negative 14, whoops, let me write that correctly. Negative 14 over negative 10, which is positive 1.4. There we go. Let me give myself some separation here so I don't bleed into the other problem. So that is the x-coordinate of the vertex. Now remember, this is tracking the height of a ball for however many seconds after it's been thrown. So this is 1.4 seconds. That's the time it takes to get to its maximum height. So if I want the actual maximum height, what I'm going to do is I'm going to take my 1.4 and plug it into the normal height equation. So remember, that looks like this. T squared plus 14 times t plus 3. Now the reason I'm putting parentheses around my t's is just so that you don't see them as plus signs, because t and plus can kind of look the same. So I'm going to put parentheses around them just to give them a little bit of separation. So all these t's are going to be replaced with 1.4. 1.4. And then you just go down the list of solving it. So in this case here, this term would turn out to be negative 9.8, plus this would turn out to be 19.6, and this would of course turn out to be plus 3 still. So you put them all together, that should be a plus 3, not a plus negative 3. My bad. All slipping today. There we go. So you're going to put them all together, and you get about 12.8 feet. So in terms of the question, the max height is 12.8 feet, and the time it takes to get there is 1.4 seconds. So it takes 1.4 seconds to get to its maximum height of 12 feet. So that is the study guide there. Again, it's mainly focusing on, can you find the x-intercepts, and can you find the vertex, and can you find out which one you're going to need in a given word problem where it doesn't outright tell you. So knowing what words mean find the vertex, what words mean find the intercepts. And then of course there's that one little question there on, can you find the intersections of quadratics and linear equations. That's the one where you have the two y's and you set things equal to each other, the fourth problem we did. So, anyway, as long as you know those things, you should be okay. Hope you enjoyed the video. Have a good day. Oh, and one more thing. The answer to the bonus question that will be on there is the word quadratic.